Okay, so hi guys, my name's Pete Smith from EnOcean. I'm going to be talking to you today about IoT for new applications, EnOcean solution examples with IBM Watson. So I'm just going to start with a little introduction to who EnOcean are, what they do, and what the problems are with conventional IoT wireless systems. The wireless sensors have overcome limitations of wide installations for the last few years now. However, conventional wireless systems require batteries. So EnOcean developed a technology which is energy harvesting. So the switches, sensors, and a number of other applications use no batteries, no wires, and with a market vision to have trillions of wireless sensors. No one can fit or replace all those batteries all the time, so EnOcean found out there was a solution required to sort that. So EnOcean have got a self-powered IoT solution which has a number of different products in the portfolio. EnOcean, the company itself, is EnOcean GmbH, which creates the energy harvesting technology and the radio frequency. However, there's also an EnOcean Alliance, which has a big booth just over that way in this hall. And there's over 1,600 products in the EnOcean Alliance. The Alliance is made up of members from all across the world, with a large majority of them in Europe. And now over 500,000 buildings across the world are enabled by EnOcean. And one of the biggest buildings actually sits in Frankfurt in the square, where there's over 10,000 sensors in that one building alone. Some of the other areas we have sensors installed are in hospitals or assisted living solutions, industrial or residential. Hotels use some of the sensors and switches as well. For example, you might have a window contact, which if the contact says the window's been opened, it will automatically turn the air conditioning off. So you can combine the data from numbers of sensors to say what you want to do, what actions you want to occur. We've also installed solutions in historical buildings, in retail buildings, and also schools and universities. We've worked in university campuses where students, especially in the UK where I'm from, are renowned for leaving the lights on, leaving the door open, leaving the windows open. So universities wanted a solution to look at both a security aspect and an energy saving aspect. So window contacts, door contacts, presence detection sensors, light switches, lots of things that can be connected to save energy for the university. And just a bit more information now about the EnOcean Alliance. So the Alliance standardizes the EnOcean Ecosystem, and it's made up of over 400 members. So you can see some of them on the screen here. There's a number of promoter members, including IBM, and they're who I'm going to talk to you about in the next few slides. We've also got the likes of Pressac, who are represented over here with my friends on the end, and quite a few of the other members are on the booth 9.1B, B60, so over there. So a lot of these members build their own sensors, switches, using the EnOcean technology, and then sell them through a variety of distributors or directly. Now I'd like to move on to the typical building control devices. So there's over 1,600 products in the EnOcean Alliance product set. However, these are some of the key products that you may have seen on stands today, and there may even be some that you've seen that people are presenting that you don't know are EnOcean. There's lots and lots of people that use the EnOcean technology, and it's shown, I think there's about 60 or so stands here today that use our technology. They've just put their own version of the faceplate on a switch, or own design on a different type of sensor. So we have light switches, we have thermometers and humidistats, magnetic window and door contacts, which I explained a little bit about earlier, presence detection sensors, CO2 sensors, and then some more intriguing ones for me, which I didn't know about when I first joined EnOcean about a year ago, is the current clamps and the water sensors and valve controllers. You can actually measure the electricity that's being used through the current clamp, which just clips onto the cable, and then you can that determine how much energy is being used. And I see nearly all of these products working across a number of different solutions, whether it be home automation, whether it be retail buildings, or even a huge office layout. And the thing I wanted to speak to you about mainly today was one of the use cases that we see as a typical use case, both in the UK and Germany, and now looking further afield as well. We did an office room utilisation project with a very large organisation in the UK. They wanted to find out how their desk occupancy rate was, whether meeting rooms were being used, which desks were preferable, how often people were sat at these desks, and so on and so on. They also put some temperature sensors in there as well, but the main use case was to find out how well their office was being utilised. The solution is made up of a number of parts. So we have the sensors from EnOcean and the EnOcean Alliance. Then we have a gateway, which there's a number of different gateways available. In this case, we use one from Digital Concepts, one of our partners on the stand. And then we had the enterprise connectivity and the analytics from the IBM side. So the key sensors were the temperature, switches, contacts, then the gateway into the Watson IoT platform, and then using some of the Tririga software as well to do some analytics on that data that they were collecting. This was the outline plan of the building that they did. There was over 600 desks in the entire one. This is just one section that we looked at. So all of the orange sensors that you can see on here, these are under-desk PIR sensors. So it says someone is sat there, someone is not sat there. It will trigger a message every time someone moves in or out under the desk, and therefore will say it's been occupied or it isn't. We had PIR sensors in all of the meeting rooms, the ones in the top right and the bottom right. And then we also had some, we did a people counting solution using a combination of a CO2 sensor and a presence sensor in the central block there. And for this whole section, we only needed one gateway, which is sat right in the middle here. And that gateway has a range typically of between 30 and 50 meters. In larger spaces, dependent on the layout of a building and how much metal there is, it may last for longer than that, but typically it's around 30 to 50 meters. We predicted that we should need 20 gateways to go across the whole solution for this client. However, when we installed the solution, we only needed 16, so it was actually more like 55 to 60 meters range, but we wanted to make sure that we'd cover every single sensor and they would be speaking to one another and to the gateway. And then these are the results that we found. Interestingly, the company thought their usage would be around the 65–70% mark across the space of a 3-month period when they installed this solution. However, the thing on the bottom right here says otherwise. So these sensors were all being monitored between 8 a.m. and 6 p.m. Monday to Friday. So the times when the majority of workers would be in the office. All of the sensors clubbered together showed that the occupancy rate was just over 30%, which is a lot lower than they thought it was going to be. And this client has a huge estate of buildings. They have about 180,000 buildings across the UK, with about 40,000 of them having multiple occupants for office-style buildings. When they saw this, they thought, blimey, that's a really low number. We need to do something about this. So what we did, partway through the proof of concept, we decided to focus on the areas that were being used the most and to see then which desks were being used in those areas, which meeting rooms were being used. And they found that the desks here on the left-hand side was closest to one of the free coffee machines in the office, whereas the desks on this side was close to the cafe where you had to go and buy your coffee. So people were populating in the area where they could get free drinks, and also there was a bit of a walkabout area just over here where you could sit and stare out the window or whatever they want to do where it's away from other people talking. So they got lots of clever insights and decided to make their estate smaller by getting rid of some of their buildings or renting out the buildings to other people. And this is the real-time view. This was from a snapshot from about 3 months ago now. And this was on a Tuesday morning at about 10 a.m. So you can see there's all of these desks here, and there's probably about 25% of them, if that, being used. And Tuesday, Wednesday, Thursday, as in most offices in the UK, are the busiest days of the week. Yet there's still only 25% of the main floor desks being used. So they've also been adding it onto the average temperature to see, is the temperature influencing where people are sitting? Tended to find it wasn't. The temperature would spike when people congregated by the free coffee machine, as you can see on the right-hand side. That was about between 7 and 9 in the morning, when most people arrive. First thing they do, go and get their free coffee. And the most popular desks, the average temperature was rising throughout the day when people had congregated there for longer and were moving around to speak to different people and going for more coffee, going to the window more, going out of the office. So this client has now decided to expand this proof of concept, and we're in discussions now to work out how far they're going to go with that, whether they want to put it into all of their office buildings, whether they want to put it into some more of the smaller buildings that they have where they may only have 5 or 6 desks. And they're also deciding whether to sell off property, cancel rental agreements, and so on. So it's a huge cost-cutting exercise for them. In our eyes, it may have gone slightly too well because it gave them better results than they were expecting and thinking they can probably save even more money than they'd hoped. But we're still working with them, and the IBM Analytics team are using some of the Watson cognitive capabilities to decide what the key aspects are that they should be focusing on across the other buildings, using the information such as the free coffee to work out whether that is a factor in all the buildings or if it's specific to this one. So I'll be sticking around for a little while afterwards if anyone's got any questions about the use case I've shown or any other use cases that we have. I just want to conclude with this slide. EnOcean self-powered IoT products offer a very practical way to implement localized switching and sensing, and it's compatible with the IBM Watson IoT environment. I don't know how many of you have looked at the Watson IoT platform and the kind of pricing model of that, but we've tended to find that if it's just small amounts of data going in and out and there's basic analytics being done, it's actually a lot cheaper than people would expect. So IBM are generally known for having quite expensive software, but here you can just use the little bits that you need and you don't have to pay for a full software product. You literally pay by the amount of data that has gone through. So it's quite a good way of testing something first